A maverick invention that can work as a time machine as well as to detect black holes. Sounds impossible? Not at all. James Webb Space Telescope is a groundbreaking invention that can probably boost human wisdom to infinity. The mystery of the origin of the universe will no longer remain unsolved. In this video, let me enlighten you about the future of science. Hey guys, welcome to your favorite YouTube channel, and today we are going to sneak into the future of space technology and the milestones it has achieved. So let's begin. On December 25th, Arianespace's Ariane 5 rocket, which was carrying NASA's James Webb Space Telescope, blasted from the launch pad at Europe's spaceport, the Guiana Space Center in Kourou, French Guiana. The telescope is an engineering marvel and the most powerful space observatory ever built. It will assist in answering fundamental puzzles about the cosmos by looking back 13 billion years in time. The James Webb Space Telescope, with its sophisticated design and ambitious scope, will be the largest and most powerful astronomical observatory ever to leave the planet. The 7-ton James Webb Space Telescope is 100 times more powerful than Hubble. Webb will observe things Hubble can't since it's an infrared or heat-sensing telescope. NASA's new and enhanced space observatory has several objectives for its journey into orbit. Not only will it be used to learn more about the Milky Way, but it will also be used to search for distant exoplanets, celestial bodies, and dark matter evidence. The primary mirror of the James Webb Space Telescope is 6.5 meters in diameter, compared to slightly under 2.5 meters for Hubble. While Hubble primarily works in visible light, the James Webb Space Telescope is a very sensitive infrared telescope that helps the James Webb Space Telescope achieve its scientific goals. Because such an observatory and its scientific instruments must work at temperatures ranging from -266 to -223 degrees Celsius, the architecture of the two space telescopes differs dramatically. To protect itself against heat radiation from the Sun, Earth and Moon, the James Webb Space Telescope, for example, has a multi-layered solar shield the size of a tennis court. The observation points varied as well. The Webb Telescope, unlike Hubble, will not encircle our planet in a 500-kilometer orbit. Instead, in Lagrange point L2, it will orbit the Sun 1.5 million kilometers distant from the planet. The second administration of NASA, James Edwin Webb, is most remembered for leading Apollo, the first space mission to take humans to the moon. He also played a key role in the two crewed space missions that followed Apollo, Mercury and Gemini. While Webb died in 1992 at the age of 85, he left a vast legacy that is worthy of a telescope named after him. It was launched on a trajectory that will take it into an orbit around the Sun to a location known as the second Lagrange point, or L2, 1 million miles from Earth, where the Earth's gravity and the Sun's gravity align in such a way that the telescope can be kept nearly stationary in roughly the same position and operate continuously for 24 hours a day. Small gas engines will also be used to keep the plane at L2 altitude. For infrared sensitivity, it's critical to keep the equipment cold. The telescope's equipment is intended to operate at roughly 40 degrees Celsius above absolute zero, so that spurious heat signals do not overwhelm the weak infrared light it receives from the other side of the cosmos. The James Webb will be shielded by a 5-layer thick shield that will block off radiation from the Sun and Earth, and its MIRI will be refrigerated by a liquid helium refrigerator, allowing it to stay cold for up to a decade away from its heated home planet, according to its designers. According to the latest reports, this space marvel is about to enter L2. The James Webb Telescope is poised to finish its 1.5 million kilometer journey to its destination, where it will see the creation of our universe. About a month after it departed Earth, engineers are preparing the world's most powerful observatory for the last correction fire that will position it in its planned orbit as it approaches the second Lagrange point, L2. During the month-long mission, the Mid-Course Correction Burn, MCCB, will correct any leftover trajectory inaccuracies and alter the final L2 orbit. Webb was scheduled to perform 3 mid-course corrections, MCC maneuvers, MCC-1A, MCC-1B, and MCC-2. MCC-2, the last fire, places Webb in its L2 halo orbit. While all Lagrange points are gravitational balance points, not all are totally stable. According to NASA, L1, the first Sun-Earth Lagrange point, is 1.5 kilometers from Earth to the Sun, and several solar observatories have been installed there. L4 and L5 are stable, while L1, L2, and L3 are metastable. L2 is a suitable site for Webb since the Sun, Earth, and Moon are constantly on the same side of the sky, shading Webb's telescope optics and equipment. This allows them to become cold for infrared sensitivity while still having access to approximately half of the sky for studies at any given time. The telescope will be gently unfolded as it flies across space until it arrives at its new home at Lagrange 2. Huge sheets of wafer-thin foil will be the first to be deployed, acting as enormous parasols to keep the telescope cool. The primary mirror of James Webb's telescope, which will capture infrared light from all throughout the cosmos, will be the next to appear. To get around the size issue, the designers at James Webb created a mirror made up of 18 hexagons of gold-coated beryllium mirrors. These will unfold like budding flowers and fit together to form a 6.5-meter mirror on their own. Everything related to this unfolding, this unprecedented automatic self-assembly, will have to run smoothly, a process that will take 6 months to finish. Only then will astronomers know if the JWST is one of the century's great technological accomplishments or a failure. On December 25, 2021, it was successfully launched on an Ariane 5 rocket. It then successfully deployed its solar array to stop the battery from depleting. It then performed the 2 mid-course corrective bands successfully. Webb then let go of its antenna. The front and aft pallet structures that support the sun shield were lowered. It finished deploying and tensioning all 5 layers of the sun shield on January 4th. Webb's team launched the secondary mirror on January 5th, 2022. Webb unfurled the first of 2 major mirror wings on January 7th. It unfurled the second mirror wing on January 8th, bringing significant deployments to a close. The primary mirror of Webb is 6 times the size of Hubble's. It is made up of 18 separate mirror pieces that were folded together for the launch. Those 18 segments will need to be recalibrated once they've safely launched, which will take around 10 days. The telescope won't be ready for scientific operations for around 6 months due to 10 days of mirror alignment followed by weeks of testing. JWST is entrusted with gathering infrared light from some of the universe's most distant stars and galaxies, and it has the largest mirror of any spacebound observatory ever deployed. The telescope will be able to look back in time with this capacity, photographing some of the first objects that formed just after the Big Bang. It will also shed light on supermassive black holes, distant alien worlds, star explosions, dark matter, and other mysteries. Distances are calculated through our Milky Way galaxy in terms of how long it takes light to travel. Over 4 light years away is the closest star. So when we look at the closest star, we see it as it was 4 years ago, not as it is now. We're witnessing the light that left that star 4 years ago and is just now reaching us. In both space and time, galaxies are far more distant. Andromeda, our nearest major companion galaxy, is around 2.5 million light-years distant. At around 60 million light-years from the Milky Way, the Virgo cluster of galaxies is the greatest nearest cluster of galaxies. The light that we see now from galaxies in the Virgo cluster began its journey toward us about the same time as the dinosaur era on Earth was coming to an end. You might glimpse prehistoric reptiles if you were in a Virgo cluster galaxy today and had a telescope powerful enough to examine the Earth. Webb will look back 13.5 billion years to catch infrared light from astronomical objects with considerably greater detail than ever before, as well as explore our own solar system and other worlds. In other words, JWST is a kind of time machine that we are going to witness. JWST will contribute to ongoing global attempts to detect Sagittarius A, the supermassive black hole at the Milky Way's core. The gravitational consequences of this enigmatic beast have been deduced, but visualizing the black hole itself has been difficult. A group of more than 200 scientists from across the world presented the first photograph of a black hole in April 2019. An array of radio telescopes used the Event Horizon Telescope, EHT, to picture the black hole in the heart of the galaxy Messier 87, M87. The image was created by the EHT team using data from 8 telescopes on 5 continents during 7 days. A black hole is generated when a star dies with such a strong gravitational field that stuff is crushed into the tiny little region underneath it, trapping the dead star's light. Because stuff is crammed into such a small space, gravity is extremely powerful. People cannot perceive black holes because no light can escape. They are undetectable. In a sense, black holes are the densest, tightly packed regions of matter known. As predicted by Albert Einstein as part of his general theory of relativity, rather than being an empty hole in space, black holes are the densest, tightly packed regions of matter known. The first photograph of a black hole showed the black hole's silhouette surrounded by a halo of incandescent gas. The heated gas created a circular shape around the black hole's event horizon, earning it the nickname Ring of Fire. It also validated expectations about the appearance of a supermassive black hole. A comparable picture of Sagittarius A star is now being created by EHT scientists. EHT, Webb, and other telescopes will use multi-wavelength observations of Sagittarius A star to assist scientists in better grasping the dynamics that regulate these cosmic predators. Recently, researchers have discovered a black hole with 200,000 times the mass of the Sun in MRK 462, a dwarf galaxy with just a few 100 million stars, using NASA's Chandra X-ray Observatory. Our Milky Way has a few 100 billion stars in contrast. Many are calling it a mini monster. The researchers utilized Chandra to examine 8 dwarf galaxies that had previously exhibited signs of black hole formation in optical data collected by the Sloan Digital Sky Survey. Only MRK 462 displayed the X-ray hallmark of a developing black hole among the 8. MRK 462 black hole is highly shrouded by gas, as evidenced by the exceptionally high intensity of high-energy X-rays relative to low-energy X-rays, as well as comparisons to data at other wavelengths. The universe's darkest mysteries are extremely distant, active supermassive black holes. These behemoths, known as Quasars, are ringed by similarly distant galaxies. Researchers have been on a cosmic treasure hunt in recent decades and have discovered the 3 most distant quasars known in the previous 3 years, each more than 13 billion light-years beyond Earth. Webb's sensitivity to infrared light, including mid-infrared wavelengths that can only be caught from space, will allow the scientists to view these objects, whose light has been stretched from ultraviolet and visible light into infrared light over 13 billion years. Webb's sensitivity and spatial resolution are unrivaled, revealing intricate features in faraway objects. The team intends to examine and analyze the data on 3 scales, carefully inspecting the quasars themselves, investigating the stars in the surrounding host galaxies after the quasar's light has been removed, and identifying the neighboring galaxies. For the next decade, NASA's Webb telescope will be the leading space scientific observatory, studying everything from our solar system to the most distant detectable galaxies in the early cosmos, and everything in between. Webb will make fresh and unexpected findings that will aid mankind in understanding the universe's beginnings and our role within it. That's all for now, guys. Drop a like if you liked the video. If you are new to our channel, do subscribe and press the bell icon to never miss another update. Don't forget to share the video with your dear ones. If you have any suggestions, please put them in the comment section. We would appreciate it. See you in another video. Until then, peace.